So after yesterday, I'm kind of a Darth version of myself with my voice, so forgive me. But some of you may be familiar with railroad diagrams, also known as syntax diagrams of this style. And the way you read this is, so they describe grammars, right, or languages. And the way you read one of these, you start at the start and follow the arrows. And you can say, okay, I first need a token with, and then optionally a token recursive. And then I have a non-terminal called common table expression that I can repeat as many times as I want with a comma in the middle. And then I keep going until the phrase is finished. And I think there's an interesting thing going on here in this diagram, which is with that little loop with the comma, right? And how do I say that in English? Well, I say one or more CTEs, whatever those are, separated by commas. But if I want to try to express that in regex, it's something like CTE and then comma CTE star. And it's unsatisfying because I have to repeat CTE twice, even though conceptually there's only one CTE being like repeated, right? And also going further, in a railroad diagram, I would represent that something like this. It's a different diagram. Or I can do the recursion on the other side, have the star on the other side, and that other diagram is also yet a third different diagram. And the same thing happens with EBNF syntax, where you can recurse from left or right. And there's something unsatisfying about all of these, in my opinion. So this back loop annotation in railroad diagrams is in my opinion, the killer feature. Now, let's look at what it took to make this picture, right? I took this from the SQLite documentation. All of their commands are documented with these diagrams. And okay, that's not very readable. And there's no connection with the syntax of this pic code and the structure, the conceptual structure of the diagram. Let's take another example. This is a really nice looking one from the JSON specification for what a number means in JSON. And it's nice and it looks really tidy and cute and it's packed. And someone was really impressed with this on Stack Overflow and said, how do you make it? And they emailed Douglas Crockford, who is one of the spec writers for JSON. And I thoroughly enjoy most things, etc., etc. How did you do these? And Douglas said, I drew them by hand with Visio. So even the specification writer for JSON could not find a way to do these automatically or with less tedium than drawing them by hand in the manual drawing tool. Right? Can we do this differently? Can we exploit the structure of railroad diagrams, of the language they're describing, and can we make things look nice automatically? Can we make use of this killer feature of back loops and do it nice and elegant in a functional way? Let's see, right? And also, I want to preserve the possibility of having those three diagrams be separate. I want to express all three of those separately in whatever language I come up with. All right, so a sequence is just a sequence, and that's an expression of three things. I can have a choice, which is a plus, so I can say plus CD, and then the third option is also a choice between F, E, F, G, and it all works. Now here's recursions, right? So I can say mu, and then do A, and then B, and then now you have a choice. And you can either do nothing, which is to exit the loop, or you can recurse, and so you go back to the beginning. What about back edges? Well, that just means that when I recurse, actually it's a sequence, I do comma and recurse, and the comma automatically goes on that back edge. And actually, you can put as many things as you want on the back edge. You can say, either do a C and then recurse, or do a D and then a choice between E and F and then recurse. And in this one, you'll see that because we're going backwards on the back edge G, E, and F, the EF choice is after D, but it's like before or to the left in the picture, right? Because it's on the back edge. So this is the JSON number spec translated to this little syntax, and it looks nice. And then you notice that there's something funny going on here. I could have written that as this, right? It's the same. It's the same. It's the same language, but it's expressed in a different diagram. And the syntax I invented lets you specify these two diagrams with different syntaxes, giving you some more expressivity. Okay, here's something more complicated. Here's something with rec ones. And so rec 1 is basically a de Broglie index for the outer loops. So I have two loops, one that starts with A, one that starts with B. And the rec 1 is pointing back to the red part, and the recs are pointing back to the blue part as a nested recursion. And everything gets laid out automatically. So this is a declarative specification with 500 lines of racket. It's pretty manageable. They're compositional, structure driven, and there's a lot of aesthetic next steps I could take. But I think one main property, the interesting research question here, is that all these diagrams are width constrained. How do I do width constrained layout in a pretty way? And so this is kind of what I call 1.5 dimensional line wrapping, which is what I want to tackle next. And there are plenty of 1D line wrapping algorithms in computer science, Flats or 3D printers and whatnot. But how do we generalize this to the extra half dimension for describing, and how do we have a language for describing these layout algorithms for railroad diagrams and not just layouts themselves? And I'll end with a cute little picture of this ancient law inscription from Crete from the 5th century BCE, and it's written in a writing style called boustrophiron, which goes back and forth like this. So this is another style that we could draw our railroad diagrams in. Okay, that's all I have. Thank you.